In this video, we're going to talk about sampling and surveys. Be warned, I have a lot of definitions for you in this video, but what else is new? So let's start with population versus sample. So we've talked about these things before, but a population, at least in a statistical study, is the entire group of individuals that we want information about. Now that's not always humans, but most of the time it's humans. And a census is the thing that we call the survey that collects data from every individual in the population. You've probably heard of the United States Census that they do every 10 years, that they survey every single person that they have registered living in the United States, and they want to collect data on those people. Now, a sample is a subset of individuals in a population from which we collect data. So visually, if you want to think about a population, it's everybody in a particular group that we are looking to collect data on, or things, not always people. And then the sample is a cross-section of the population, which you can gather in a number of ways, which we'll talk about in this chapter. So that sample is a smaller group within that population that is meant to represent the data as it would be across an entire population. So let's try to figure out population versus sample in these two examples. So this one has to do with sampling monitors and voters, because why not? So this first one is the quality control manager at a factory that produces computer monitors selects 10 monitors from the production line each hour. The manager inspects each monitor for defects in construction and performance. So which one is population and which one is sample? So we would say that the population is all the monitors produced in the factory in a given hour, and then the sample are those 10 monitors that the manager selects from the production line during that hour to test for quality control. The second one is prior to an election, a news organization surveys 1,000 registered voters to predict which candidate will be elected president. Which one's the population? Which one's the sample? So for this one, the population is all registered voters, and the sample is going to be the 1,000 voters that this organization surveyed. So as we mentioned at the top of the video, there are things called sample surveys that are studies that collect data from a sample population that is meant to represent a specific population. So it's meant to mirror this population, but obviously with a smaller group size. Before we get to the good stuff, I want to talk about the not so good stuff, and that is specifically how to sample badly. I don't think it would come as a surprise to you that there are ways to survey folks and write questions that are just bad, that will not give you the desired outcome if you are genuinely trying to collect data. So the first one is something that we call convenience sampling. Now that is literally what it sounds like. It's a group of individuals from a population that you survey who are just really easy to reach. So let's say you wanted to survey all of the college students on a campus and you wanted to know what their favorite classes are or what they spend the most time on. Now this is like the entire college population. If you stood outside of, let's say, the math and science building, you're only really going to get math and science students or people on their way to those classes, typically. So although that's convenient, it's really not going to give you a great sample of the entire community. So convenience sampling often produces unrepresentative data. If you're lazy, you're not going to get the greatest results. The second is what we call voluntary response sampling. So that allows people to choose to be in a sample by responding to a general invitation. So although that sounds great, like you'll get voluntary participation, but that sample is only going to be people who are willing to answer that question or those questions. It's not the greatest way to collect data. And then, of course, something that happens in writing surveys and collecting that data from the surveys is something that we call bias. You are familiar with that word. But the design of a statistical study shows bias if it is very likely to underestimate or very likely to overestimate the value of what you want to know. So bias is not just bad luck in one sample. It is usually baked into the questions or the sampling methods, or both. So we're obviously trying to avoid these three things: convenience sampling, voluntary response sampling, and obviously bias. This is probably my favorite example that we've done so far, and probably for all time. It is called Boaty McBoatface. Yes, bias sampling methods. So here's the background. In 2016, Britain's Natural Environment Research Council invited the public to name its new $300 million polar research ship. To vote on the name, people simply needed to visit a website and record their choice. Ignoring names suggested by the council, over 124,000 people voted for, you guessed it, Boaty McBoatface, which ended up having more than 3 times as many votes as a second place finisher. What that was, I'm not sure. So what type of sampling did the council use in their poll? And let's explain how the bias in the sampling method could have affected the poll results. So the council used voluntary response sampling, where people chose to go online and respond. And the people who did respond were probably less serious about science than, well, we'd like to assume, than the British population as a whole, and far more likely to favor a funny name like Boaty McBoatface. So the proportion of people in the sample, those that voted, who voted for Boaty McBoatface, is likely to be greater than the proportion of all the British residents who would choose this name. So not a great sample, and through voluntary response sampling, this is what you get. You get Boaty McBoatface. Okay, now that we've covered some of the bad stuff, how do you do this well? Well, it all comes down to randomness. Now, we prefer random sampling, and that involves using a chance process to determine which members of a population are included in the sample. So just a little note about using random. I don't know how popular it is among your vernacular, but it was very popular in my time. When people would be like, that's so random, when they really mean that's so haphazard. Where in stats, where we say, that's so random, it means, wow, that really used chance. And that's a probability element, which we will cover very soon. So please don't say that a sample was chosen at random if a chance process wasn't used to select the individuals, like, Boaty McBoatface. So the result is something that we call a simple random sample, or an SRS. And that is a sample of size n, so whatever number you have, that's what n stands for, is chosen in such a way that every group of n, that same number of individuals in the population, has an equal chance to be selected in the sample. Hence, random, or using chance. So the important part of an SRS, or a simple random sample, is that your sample is truly random. And one great way to do that is to assign number values to all of the individuals in a certain population that you're going to pull from to make your sample. So, tried and true classic way to do that, especially if your sample is small, is to draw names or draw individuals out of a hat. Now make sure that your pieces of paper are all the same size and folded the same way, same color, so there's no bias. But yeah, you've done sampling before, I'm sure. There's also random.org and other random number generators, especially if you have a large group that you want to sample from an even larger population. So here's how to choose an SRS, or a simple random sample, with technology, because technology is our friend. So 3 steps here. Label. You want to give each individual in the population a distinct numerical label from 1 to n being the number of individuals in that population. Randomize. So you want to use a random number generator to obtain n different integers from 1 to n, where n is the sample size. And then select. You choose the individuals that correspond to the randomly selected integers. Now, in probability speak, when we make selections using a simple random sample, or an SRS, we do so without replacement. And without replacement means that once a number is used, it is not replaced back into the population, hence without replacement. Because once it's chosen, you can't choose it again. And your calculator, your TI 89, 83, 84, your Inspire, whatever you got, that will actually choose random numbers for you. So let's say we want to use our calculator to select 10 students from a population of 1,750, labeled 1 through 1,750. When you press the math button, you're going to go over to the probability menu, and you're going to go down till you see this rand int, which is a random integer generator. Now on a newer OS, that's usually the TI-83 and 84. Anything with a color is usually newer. So it'll give you an opportunity to enter in a lower number, so that would be 1, and an upper number, so it's essentially all the n values that you have. So if you have 1,750, it's going to go from 1 to 1,750, where n is 1, which just means you choose one random number, you hit enter, and you hit enter as many times as you need. In this case, it would be 10, because we're picking 10 students. If you have an older OS, which I think they mean is a TI-89, but I don't have one of those, so I cannot be sure, or even older. So you would complete the command, the same thing, math, probability, random integer, and you would just do 1 to 1750, hit enter, and you hit enter 10 times to get however many random numbers. Now, if you have a more updated one, especially the TI-84 Plus Color Edition, you actually can enter in that 1 to 1750 range of n values, and then there's this next thing that you can enter in, which will give you 10 numbers. So if you put in 10, it'll give you 10 random numbers. If you put in 100, it'll give you 100 random numbers. So your calculator is able to do this either one by one or give you a large batch of random numbers. So remember, you attach those random numbers to the individuals in a population, and that way you can randomize the folks that you're going to survey. All right, that's going to do it for this video. Thanks for watching.